Hello everyone, good evening. So here we shall solve some KCET previous year questions on the chapter Electromagnetic Waves. So any doubts if you have steps, then please mention that in the comment section. And any other chapter of physics, if you have more, also mention the name of that chapter in the comments, so that we can give more clarity on it, solve more and more questions. Also some important homework questions included in the Sapience application. So please install our Sapience. Link has been included in. So here the first question, note that if mu naught the permeability of free space and epsilon naught is the permittivity of free space, speed of light is, you know that the speed of light, that is c, is 1 by square root of 1. So option A is the correct answer. So question number 2, it is told which of the following statements does not hold for thermal radiation. The wavelength changes when it travels from frequency change travels from one speed change. Straight line. So frequency does not change when it travels from one medium. Option B is the correct answer, since is the wrong statement. Then in question number 3, it is told electromagnetic wave consists of periodically oscillating electric and magnetic vectors. Electromagnetic wave consists of periodically oscillating electric and equally perpendicular planes vibrating with a phase difference by equally perpendicular planes but vibrating, equally perpendicular but vibrating. Option D is the correct answer. So they do not have any phase difference, so they vibrate in phase, but they periodically oscillate in equally perpendicular planes. Option D is the correct answer. Then in question number 4, an electron enters the space between the plates of charge capacitor as shown. The charge density on the plate is sigma. Here we have charge density plus sigma. Here we have the charge density as minus sigma. The electric intensity, one electron is there which enters the region of the two plates. Electric intensity in the space between the plates is E. Electric intensity in the space between the plates is a uniform magnetic field also exists in the space perpendicular to the direction of the electron. The electron moves perpendicular to both electron moves perpendicular field and magnetic field without any change in direction. Time taken by the electron to travel distance L in that space. So here force means the electric force on the electron that should be equal to the magnetic force on the electron, and it should be equal and opposite. The electric force is upwards, the magnetic force will be V cross B downwards, magnetic force is downwards. Therefore Q, that is E into E, that is equal to E. Therefore the velocity of the electron is by B, and the electric field is given as sigma by epsilon naught. So V will be equal to sigma by epsilon naught into B. It is moving with a uniform speed, uniform velocity. So therefore, the time taken, that will be equal to the distance by speed. Time taken is distance covered by the electron by distance by velocity. So therefore, T will be equal to the distance L by B. L by sigma by epsilon naught. So T will be equal to epsilon naught LB by C. And C is the correct answer. Then in question number 5, it is told X-rays, gamma rays, and microwaves traveling in vacuum have same velocity but different wavelengths. Same velocity, but they do not have same frequency. So option C is the correct answer. They have different wavelengths, but they travel with the same velocity, which is the speed of light. Then in question number C, it is told a charged particle Q with a velocity v, that is 2 into 10 power 3 meter per second, passes undeflected through electric field and magnetic fields in mutually perpendicular. So suppose the electric field is like this and the magnetic field is outwards. That means that QV field is inward. That means that QV cross B, the magnetic force is upwards. The magnetic force is upward, which is QV, and the electric force that is downwards. Then it is told that the magnetic field is 1.5 Tesla. The magnitude of the electric field will be how much? So therefore, we can tell that since the charge is moving undeflected, therefore the electric force should be equal and opposite to the magnetic force. So therefore, the electric force should be equal to the magnitude of the force, that is VB, that is equal to V. So VB, that is equal to E by. So we have to find the magnitude of the electric. Therefore, V is given as 2 into 10 power 3. That is equal to E by B. B is 1.5. So therefore, E will be equal to 1.5 into 2, that is 3 to 10 power 3 Newton per Coulomb. Option C is the correct answer. Then in question number 7, it is told that a plane electromagnetic wave having a frequency of 20 megahertz travels through the space to x direction. If the electric field vector at a certain point in space 6 volt per meter, what is the magnetic field vector at that point? You know that E by B, that is equal to C. So therefore, the electric field that is told, that is 6 volt per meter at a certain point. What is the magnetic field vector? It means that volt per meter divided by B will be equal to C. C is equal to, we know, speed of light, that is 3 into 10 power 8 per second. So B will be equal to 6 by 3 into 10 power 8. That will be equal to 6, so 2 to 10 power minus 8 Tesla. So option B is the correct answer. Question number 8, it is told that electromagnetic radiation used to sterilize milk. Electromagnetic radiation used to sterilize means we have to sterilize milk means to kill the harmful germs in it. So that can be killed by the ultraviolet radiation. UV rays. Option C is the correct answer. Number 9 is told if E and B represent the electric field and the magnetic field of an electromagnetic field, then the direction of propagation of the wave is the K cap, that is given as cap cross E cap. It means, and this is called the propagation. It means the electromagnetic wave will propagate in the direction of E vector cross E vector. And D is the correct answer. Question number 10, it is told an electromagnetic wave is traveling along the X direction with electric field vector along the Y axis. So the electric field is moving, is oscillating along the Y axis. So Y, that is given as E naught sine kx minus omega t. The correct expression of magnetic field, the correct expression for magnetic field, the function is kx minus omega. So it means the electromagnetic wave is traveling along the positive direction of x axis. That means here the propagation is with propagation. So the propagation the unit vector along the propagation vector is always along E cap cross B cap, and which is equal to I cap in this case. Therefore, now E cap, that is equal to J cap. So it means that the J cap cross K cap means I J K. J cap cross K cap is equal to I cap. So therefore, the electric field, the unit vector along the electric field is J cap, and the unit vector along the magnetic field, that will be K cap. And so the propagation vector, that is along I cap. Therefore, the magnitude of the magnetic, therefore the magnetic field will be along Z axis, Bz equal to B naught sine Bz equal to B naught sine kx minus omega k cap, where B naught is given as E naught by c, where c is the speed of light in vacuum. So it means that option C is the correct. Question number 11. Question number 11 it is to a normal light beam of intensity 20 watt per centimeter incident normally on a perfectly reflecting surface. Intensity is 20 watt per centimeter square. Incident normally on a perfectly reflecting surface. Here there is only reflection, there is no absorption. So here the side length 25 centimeter, the second height is 15 centimeter and the length is 25. The momentum imparted to the surface by the light. The momentum imparted to the surface by the light per second. So therefore, the momentum is imparted. Momentum imparted P is equal to so P is equal to E by C. E by and energy that is equal to intensity. Intensity is equal to energy by time into is the power by area. Power by area. So P is equal to energy which is I A into T. I A into T divided by I A into T. So therefore, momentum that is imparted per second. Momentum imparted to the surface per P by T equal to I into A by C. So here the area of the surface that is given as 25 centimeter into 15 centimeter, which will be equal to 25 into 15 in 10 power minus 4 meter square. It is 3 into 10 power 8 per second. The intensity is 20 watt per centimeter square. So this we can write 20. The area we can write it as centimeter square. So 25 into 15. So I into A, that will be 20 watt. 20 into 25 into I into A by C is 3 into 10 power 8. This much kg meter per second. 3 5 is 15, so 5 2 is 10. Therefore, this will be equal to 100, it means 10 power 2 into 25 into 10 power minus 8 kg. So this will be equal to 2.5 into 10 power 3, so 2.5 into 10 power minus 5. Actually, it will be 2 E by C since there is only reflection. Only reflection. 2 E by C. So into 2 also have to into 2. 5 into 10 power minus 5 kg meter per second. Option A is the correct. When there is only absorption, then the momentum will be given as 2E. Then it will be given as E by C. When there is only reflection, it will be given as P is equal to 2E by C. reflection. Question number 12, it is to suppose that the electric field amplitude of the electromagnetic wave and its frequency is given as 50 megahertz, and which of the following value is incorrectly computed? Magnetic field amplitude is this. So the magnetic field amplitude B, that will B naught, that will be E naught by C. So this is 120 by C, that is 3 into 10 power 8. This much Tesla it will come. 4 are 12, so 4 into 10 power minus 7 Tesla, or I can say 400 into 10 power 9, which will be 400 nano Tesla. 400 nano Tesla. Then B. So the first option is correctly computed, and the angular frequency of the electromagnetic wave, which is omega, that will be 2 pi into f. So that will be 2 pi into f, which is 50 megahertz. So 50 into 10 power 6 hertz. That will be in radian per second. It will be 100 pi. That is pi into 10 power 8. So this is also correctly computed. And then the propagation constant of the angular wave number, that is C, that is equal to 2 pi by lambda by 2 pi lambda is equal to T by T. I can write it as omega by K. T is equal to omega by K. So K is equal to omega by C. Therefore, K I can write it as omega 5 into 10 power 8 divided by C, that is 3 into 10 power 8. That is equal to pi by 3. Or I can say 3.14 divided by 3, that is approximately 1.05 radian per meter. And option D is wavelength of the electromagnetic wave lambda, that is equal to T by F. So that will be 3 into 10 power 8 divided by 50 into 10 power 6. That will be 100 by 50, that is equal to 6 meter. Therefore, all the options are correctly computed, but except the option C. Since in option C it is told the angular wave number is 2.1 radian per meter, but actually it should be 1.05 radian per meter. Option C is the correct. Then in question number 13, it is told that the source of the electromagnetic waves can be charge with a constant velocity. Charge is moving with a constant velocity. Charge moving in a circular orbit. Moving parallel to a magnetic field. If a charge is moving parallel, so whenever any charge will move under some acceleration, there is some accelerating charge that will always produce some electric wave. Moving parallel to the charge. So it means that when it moves in a circular orbit, then the charge is moving under acceleration. So it will be a source of electromagnetic field. Option B is the correct. Question number 14, it is told which of the following radiations deflected by electric field. So gamma rays, these are electromagnetic waves, so these will not be affected by electric field, and neutrons have no charge. That is why they are also not affected by electric field, but alpha particles are having positive charge. Alpha particles have plus 2 units of plus 2e, yeah, positive charge. So they will be affected by electric field. Means they will be reflected by the electric field. Option C is the correct. Then we should solve the last question, number 15 of this chapter on electromagnetic waves. So which of the following radiation electromagnetic highest wavelength? So we know that in the electromagnetic spectrum, the waves that are in the electromagnetic waves that are included are, first one is gamma rays, and ultraviolet rays, visible light, with geo. Then after that we have infrared, and then infrared waves, microwaves, we have radio waves. So here, so from left to right, the wavelength increases, and from right to left, the frequency in all of them have the same speed, with the speed of infrared wavelength, and then X-ray is here, ultraviolet is here, microwaves. So microwaves is towards most right. So microwaves has the highest among the microwaves has the highest among these. So option C is the correct answer. So hope all of you have understood the solutions of these 15 questions, and any doubts if you have, then please write that in the comments. I'll verify them in the subsequent videos. And please install our Sapience education application, where we shall upload some important questions based on the previous year KCET exam. Thank you, everyone. Bye.